Recording, okay. 29. Recording at the beginning. And I was saying this. Okay. So as I mentioned in the last class, I'm not happy with the result of the exam too, especially because our course is easy and I'm not going too fast or I'm not giving you extra difficult questions. So if some students are getting D's and F's, it means that we're doing bad, right? And I think there is this misperception about me and my class based on last semester that the students think, oh, just go and then tell her you care and then you'll get an A. So last semester was an exception because the students were going through transition. It was difficult for them. So I gave so many extra credits opportunities. Still, I am doing that this semester, but by going to tutoring. But if you're failing the course right now, it's likely that you're going to fail unless you change what you're doing. And by change, it's like studying. So how many of you are studying outside of our class time, outside of our tutoring, outside of taking the homework? Are studying 3 hours? I didn't say the question yet. You're studying 3 hours or more each week. You see, this is like few of you. So, and students tend to not study like during the normal weeks right now. And then when they have an exam, they study 20 hours per week. And they say, I studied so much. When you don't study each week, you cannot keep up with what I'm teaching, okay? And if you have questions about how to study, I have students in my other class, they're studying, but still they're not getting a good grade because they don't know how to study. So if you have any questions, concerns, we have academic coaching at campus. We have extra resources available, and you can just talk with me. You know, I try to convey so far that I'm approachable, I'm understanding, you know, I'm not unkind, I don't know, however you want to put it. So just reach out to me, talk to me, and if you decide that you want to pass this class, I make sure that happens. But you should study, you should contact me, we should have tutoring and all that. Okay, so I bore you more with what I'm saying. Everyone did the attendance and, you know, chose the times that work for you. So based on the results, I'm going to send an announcement and then have some tutoring sessions or office hours, whatever you want to call it. Even if you're watching this at home, hopefully if you're watching this, please pick the times for office hours or like tutoring sessions that work for you. And if you're getting like F's and D's specifically, as I said, I'm going to schedule makeups for you if you want. And so far, 3 students only messaged me, and 2 of them were asking about like quiz 3, not exam 2. So I don't know. I feel like, you know, if you had the opportunity, it's good to take advantage of it and then retake the exam if you didn't do well specifically. Okay, now going to our lecture. So first I want to address 2 things that we talked about during the last class, and I told you that I do investigate more and then come with an answer. So if we have more than 2 substituents, we don't use para, meta, ortho anymore. We use the traditional system that we had before. So for instance, if we have this compound on the left that I wrote here, can anyone explain to me how we can write the name of this compound? And this is the other thing. In my 101 class, I tell the students, I tell them, okay, this is the definition of element. And I have the definitions on the board, and I tell them, can anyone tell me what is an element? And they just read from the board, word by word, and then when I give the exact same thing in the exam, they don't know the answer. So I have like the answer sometimes on the board to, you know, help you, guide you to name the compound, but make sure to know how to name them without the solution. I guess that's obvious. So can anyone explain this? Yes?
Like how to name that compound?
Yes.
So because there's more than 2 substituents, you name them by their numbers. So they're at 1, 2, and 4. Methyls, and it's on a benzene.
Exactly. So why didn't we start naming here, for instance, from here, 1, 2, 3, 4? Why didn't I do that?
always the one on the top?
So,
Or with a double?
There's more consecutive constituents, like starting from the top.
yes. So in that case, so when you're talking about naming toluene, for instance, if you have CH3 and then we have one chlorine attached to it, so that's right in that case, and then we have some examples in the next slides that we go through. Question?
It's based on where the second branch is.
Exactly, as your friends mentioned, we have like, two methyl here, but we have one here. Remember way back when we were talking about naming alkanes, we said we name in the direction that we have more groups, right? So if we had like, I don't know, another branch here, for instance, CH3, we could also start here, right? But in this case, I delete this so I don't confuse you. In this case, we have like two groups here, one group here. That's why we start naming from here, blue. Right, I guess I just eliminate these ones. Sometimes the students don't come to the class and then they don't listen to the lecture. And I had one student, as you saw on Canvas, everyone that failed the test, I made a comment that reach out to me so we can talk about 275. I did the same thing for my 101 class, and then the student reached out to me and then said that I cannot follow your lectures. I'm just looking at the PowerPoint slides. And I'm like, what am I doing wrong? Just tell me how I can improve. So what I'm saying is that some students don't listen to the lecture, whether they don't have time or they don't understand what I'm saying. And then they just look at the PowerPoint, so I don't want to have like confusing numbers there. So that's why I eliminated the one that was incorrect. Anyway, so if you accept from us that you start naming from here, right? You have 1, 2, 4, as your friend mentioned. You have 3 methyl, so we call trimethyl, and we have a benzene ring. Yes?
So we talked about having benzenes that had the methyl group, calling it a toluene.
Mm-hmm.
Why wouldn't you say that it's like a 2,4-di methyl toluene?
Great question. So what your friend is asking, probably people can hear if they listen to the video, but I just try to repeat the questions in case people don't understand. So your friend is saying that when we have like methyl here, you told us to call this compound toluene. So why we don't call this compound, like, name the substituents and say toluene? So the answer is that is correct too. And I have some examples as follows, and your friend mentioned last class too, so what about that? So when you can, sometimes you can't, and we have examples, but when you can name it alternatively, that is correct too. And I don't give you both in exam, so it would be confusing, So, but you should be able to use both systems. Great question. So let's look at this one. So this is the answer to the question that you just asked. So here we have toluene, and as we said, we have like a CH3 attached to a benzene ring. So you can also call that methyl benzene. And the reason we don't specify one, or like we don't put a number, is that it's just like one possibility, right? Remember, when you name compounds, when there is only one possibility, we don't have to put a number. For instance, we should say 1 butene, 2 butene, or which isomer we have, because there are different possibilities. But for propene, it's just only one structure possible, for instance. And the same thing here. Can anyone see that why we don't write 1 methyl benzene or 2 methyl benzene? Everyone can see that? Because even if I put this structure here, not here, even if I do this, the structure is equivalent to the other one. And you may wonder, you may ask me, but here, I guess no. I wanted to say that here you have like single, double, and here you have single, double too. So these structures are equivalent wherever you put methyl. Does that make sense? Any questions? So here, what about the structure on the right? So we learned that this NO2, we call that nitro, and then this is methyl, right? Do you remember what was these locations here and here? What did we call those? Yes, exactly. In general, we call them ortho, meta, para. And I told you, I mean, anytime I try, as I said, anything that I ask you to remember, I make sure that I know myself too. And anything that it's difficult for me to remember, I think that it's hard or it's unfair for me to expect you to know. But here, I was like thinking that if you have CH3 here and then have another, for instance, NO2 here, these two substituents are close to each other. So this is like ortho, right? If these are like kind of, they're not parallel, but if you shift one of them, it would be kind of parallel. So they are like furthest, we call that para. And if it was like in between, one double, one single bond between them, we call that meta. Any questions? Good? Okay. So now this is meta. And maybe you can just like remember without having anything to remember it by, but as long as you know. So this is meta. And then I told you this is nitro, and we call this compound as itself toluene, a benzene ring that has CH3 attached to it. But as your friends mentioned this session and the previous session, you say, what about, I say this is a benzene ring that has CH3 and NO2. That is correct too. So what we do is that, I guess I just talked about this first. So we say 1, 2, 3, we call that 1 methyl, 3 nitro benzene. And in this case, we do alphabetically, right? Methyl, nitro, M is before N. So we say 1 methyl, 3 nitro benzene. Or we can still call that toluene, right? And use the numbering system. And as your friend mentioned at the beginning of the class, in this case, because we have like toluene, our compound is toluene, we start counting from here. We say 1, 2, 3. So we call that 3 nitro toluene. Does that make sense? Any questions? Yes.
Is any one of these names preferred? Like, is there any one name that you would go to first because it makes the most logical sense, or would any of those three names work?
Any of those three names work, but sometimes, chemists say that, okay, we want to specify this is a toluene.
Right.
So they go with like 3-nitrotoluene or like meta, or they want to emphasize that meta, ortho, para. So I guess you can say maybe this one they prefer, but it doesn't really matter, which of name you use. But in this case, you have like more information. Maybe if you just see this, I mean, with practice you can see the structure. So even if I tell 1 methyl 3 nitro, you imagine the structure, you're like, oh, we have methyl, so it's toluene. But if you don't have much practice, maybe it is hard to see at first, so maybe this one, but all of them are correct. You should know all of them. Good? A question. So now I have like some more examples listed here. So again, if you want to name this compound, and these are like, as you see, equivalent, they have like different colors because I wanted to emphasize on how we name each of these. So let me change my color. Okay, so if you see CH3 attached to a benzene ring, so you know this is toluene. Okay, and if you decide that you want to name this compound toluene, you should start naming it from CH3. Okay, does that make sense? Good. So we say 1, 2, 3, 4, 5, 6. And in this example, it doesn't matter which direction you go, because the other way also it says 1. If I go the other direction, it would be like 1, 2, 3, 4, 5. It would be 3, 5 anyway. So in this case, it doesn't matter. And then you specify the substituent's carbon number, that the carbon numbers that substituents are attached to, which is 3 and 4. You have 2 chlorine atoms, right? So you call that dichlorotoluene. Are we good with the first way of naming this? Okay. Now the second one, let me have like this color. Okay. So if you want to name this compound, you may say that, okay, I want to name it as benzene. If you decide to do that, you should start naming from one of the chlorines. Okay?
Is it because it's alphabetical?
Exactly. So here, if you look at it, even if you go, so they are like, they have like one double, one single bond in between of all of them, so they are kind of like symmetrical. So in that case, any direction that you go, the number of second substituents that you encounter would be the same, right? So in the previous example that we gave, two chlorine were next to each other, so you had to go in that way. Does that make sense? But in this example, as your friend mentioned, because we have like chloromethyl, we first cross chlorines. Okay? Does that make sense? So I don't do like this. Say 1, 2, 3, 4, 5. Because the number of chlorine atoms in that case, the number of carbons that have chlorines attached to it would be 1 and 5. But in the other one, the original one that I wrote, it would be 1 and 3. Does that make sense? Yes.
So, usually when we name compounds that have double bonds, we make sure to go through the double bond.
Uh-huh.
The examples, we've been going through the double bond, but it's still important with benzenes. Is that correct?
So the great question. So what your friend is asking is that how come we don't make sure that we pass through the double bond?
Because I remember talking about it, and some of them don't apply.
Exactly. So can anyone answer this? Yes.
Has something to do with the double bonds shift so frequently that
Uh-huh.
it doesn't really matter.
The cake cool something.
Yeah, calculate. Yeah.
Cool.
Exactly. So we denote benzene rings as like this. So we say that they have like double bond and single bonds that they alternate. But as you guys remember, we had like calculate structure that was saying that, we have like this structure. We also can have the other structure, basically putting, double bonds. We can put them like here that they alternate, have this conjugated structure, or here, right? And these two exist, almost at the same time. They just like, shifting so quickly. And as you will see in the rest of the chapter, and we talked about this briefly in chapter 1 too. Do you remember what we called the structures that they have like the same bonding pattern, or like, the structures are the same, just the location of electrons are different. For instance, in these two structures, what's that?
Isn't it an isomer?
So isomer wasn't location of electrons. Remember, that was like we had like different isomers too, but one type of isomers was like when molecules had like the same chemical formula, but the location of atoms were different. Or sometimes they have like the same, structural formula as well, or like their structure is almost also the same, but when we rotate them in the space, we could get different configurations. Remember, we call them conformers, conformational isomers, right? Or like cis and trans, that they were configurational. But when the structure is the same, just the location of electrons are different, yes?
Was it resonance structures?
Exactly, resonance structures, right? So what we're going to learn, and we kind of talked about this before too, benzene rings, they don't quite have double rings. So it's not like that we have like this structure by itself. Whether you can say that these two structures exist almost at the same time, or you can say that we can have kind of like this structure. So basically denoting this resonance, or denoting that these double bonds kind of alternate so quickly that they almost exist at the same time. So in a nutshell, these bonds, they're not like single bond, double bond, single bond, double bond. They're like different type of bond, something in between. Does that make sense? So that's why we don't abide by alkene rules. And that's also why they don't go through addition reactions. They go through substitution, kind of like alkanes. And we said that these structures are really stable. Any questions? Good? Okay, and then when we go with this naming system, I guess I also delete these guys. It would be 5-methyl benzene. 1 and 3 dichloro, 5-methyl benzene. Good? Okay, now any volunteer to come to the board for 5 points extra credit to draw this structure. And as I said, it doesn't need to be correct as long as you volunteer. Yes? Huh, where is the... Oh. Somebody stole our pens. I guess we can just draw here.
Okay.
Can you explain how you do it to your
Yeah,
friend?
so you have your benzene,
Uh-huh.
and then the toluene is the methyl at the top, right?
Uh-huh, yeah.
And then your fluorine, so that automatically makes it 1.
Okay,
Correct.
yes.
So then,
You can also put the numbers so it
Okay.
would be easier for everyone
so
to see.
CH3.
Uh-huh.
So then you'd have a fluorine, and then on 2,
Uh-huh.
I guess we can number these.
Yeah.
5, 6, and a fluorine on 6, and then on 4, you'd have an ethyl.
Uh-huh. Exactly. Thank you. So can everyone see how your friend did that? So you can, as she said, you have like toluene, so you know that you have CH3 attached to a benzene ring. And remember, in your exam, I give you this structure, but instead of 3 double bonds that they alternate, I give you 2 or like 1. And sometimes the students are just focusing on substituents, they forget to actually see the benzene ring, right? So make sure that you see that and pay attention to that. And then you can name, as your friend did, 1, 2, 3, 4, 5, 6, right? And then see what substituents you have. You have carbon number 4 that you have an ethyl, right? And everyone can see what this is ethyl, right? This is CH2, this is CH3, and C2H5 was ethyl, right? Can anyone name its alkane? Exactly, C2H6, right? Ethane. Anyway, so remember that. So she knew that when we have like 2 executive lines, this is ethyl, but if it's confusing to you, write the hydrogens as well. And 2 and 6, difluoro, di means 2, fluoro F, so we have like 2 and 6. Any questions? Good. Okay, and also I wrote this here, so, but you already have the naming from here, because here we said we have toluene, so we start naming from this methyl, right? We say 1, 2, 3, answer from the previous slide. And now you may wonder, what about benzene? I like to name this compound somehow, that has benzene in it, right? So that is correct too, you can just do that too. But if you decide to do so, you should remember that now we don't start so on and so forth. But here, you go from the direction that you encounter more substituents. Okay? And if it was the same direction or it didn't matter, you go alphabetical. But in this case, I say 1, 2, 3, 4, 5, 6. Is it clear for everyone why, if you want to name this compound benzene, why we do this, not the other numbering system? Any questions? Are we good? Okay. So in that case, we say this is 1 and 3 difluoro, right? And now I'm thinking alphabetically. Is it like probably, yeah, here. Yeah, I didn't consider alphabetical order while writing this. But for now, we have like 1 and 3, difluoro, 5, ethyl, 2, methyl, benzene. But when we want to write it, yeah, this is the alphabetical order, right? So it probably should be 5, ethyl, 1 and 3, difluoro, 2, methyl, benzene, right? Yeah, when I was writing this, I didn't pay attention to the alphabetical order. So the alphabetical order, when we have like more substituents, that is the last step, just when you're writing it on paper. Does that make sense? So we call this one 5-ethyl, and just like, yeah, chicken. Yeah, and then you consider ethyl, fluoro, methyl. As you remember, we don't consider di or tri because that just denotes the number of atoms, right? When you want to see the alphabetical, just see what group you have as itself. So it would be 5-ethyl, 1 and 3 difluoro, 2 methyl. Probably when I was writing it, I didn't pay attention, or maybe I thought it's difluoro. Any questions? Okay, now I want to talk about something that you previously knew. We talked about aromatic compounds, basic compounds that they have a benzene ring, right? Now we add that these type of compounds, we call them arenes. Okay. And do you remember that when we had alkanes and then we eliminated, I guess I read eliminating one hydrogen, we said we call them alkyl, right? Now, if we have like, an arene and we eliminate one hydrogen, we call them aryl group. So alkane, in alkanes, when we eliminate one hydrogen, it would be alkyl. In arenes, when we eliminate one hydrogen, it would be aryl. Okay? And there are 2 substituents that I asked you to remember for your exam. One of them is phenyl, which is basically you have benzene C6H6 that we eliminated one hydrogen. It would be C6H5. So we call that phenyl. And the structure is like this, meaning that this, carbon here, you see that the valence is 4, and now it bonds with another substituent. It's not hydrogen anymore. Previously it was hydrogen, right? But now we eliminated this hydrogen. Remember that, this is benzene, right? And then we have carbons here, and they attach to hydrogen. If we eliminate one hydrogen, that would be phenyl. We have another substituent that we call that benzyl, which is C6H5CH2, meaning that you have like your benzene ring, and here it attaches to one CH2 and then attaches to something else. And I give you some examples, go through them for you to better understand this. But as of right now, remember that phenyl is a benzene ring that you eliminate one hydrogen and you attach something else to it. So this is phenyl group. Benzyl, you have like this, you eliminated that hydrogen, but you attach that benzene to a CH2 and then attach it to something else. We call that benzyl. Okay? Good? It's kind of like definitions or like names that you should remember.
So is toluene technically a phenyl group?
Is toluene technically a phenyl group? So this is, let me see. You have like here CH3. So I guess you can argue that. Yeah. Great question. Any other questions? Okay. Now, I have some examples for you from your book. And this is another thing that I try to emphasize. Read your book and go through the solved examples. Most of the things that you see on the exam are from book, like solved examples or like problems. So I highly encourage you to go through the examples to solve as many problems as you can. And then if you have questions, go to your tutor, come to me, ask me. So you'll be prepared for the exam as much as possible. So here we have like, this benzene substituent, right? And then we have something attached to it, right? So there are like two ways to name these compounds. So I first start with one of them. So do you remember what we call this compound that I listed here? Or like this one, the whole structure? Or how did we name this one, this alkane?
In the longest chain.
Uh-huh.
Branch closest to the.
Exactly. So we name it like 1, 2, 3, 4, 5. We name it somehow that we encounter the substituent first, right? So that's why we say 2, and then we have chloro, and then this is a pentane, right? So now you have the same structure here, but in carbon number 2, instead of I substitute just one chlorine atom, I substituted a benzene substituent, right? An aryl substituent, right? And what was the name of this substituent? Remember? So if you get confused in the exam, you just write this for yourself. What was this? Phenyl, right? We eliminated one hydrogen. Yes?
Sorry.
No worries.
So would you use phenyl and benzyl if it's a substituent? So that's when you would use those two, or could you use phenyl in other situations?
So these are, substituents. It's kind of like alkyl groups.
Okay.
So they are like mainly substituents, in other compounds,
That helps.
right? So you can just what I did, name one other compound, say, okay, 2-chloropentane, but now, don't be scared that you have like a bigger substituent, but still it's a substituent. So you call that 2, whatever this one is, pentane. And then you ask yourself, what is this? This is phenyl. 2-phenyl pentane. Yes?
So if that was connected to a CH2, would that be considered benzyl?
Exactly.
So since it's CH, it's phenyl.
Exactly. So because here, because you have this structure is phenyl, but if you had the same thing, and we have like more examples there too. If you had something like this, whether like CH2 or kind of like this, and then this would attach to whatever else, that would be benzyl. Does that make sense? But here, this is attached to one carbon, and then you can also write the expanded structural formulas for yourself.
So if that had like an ethyl group, how it comes down and turns, and then had the benzene structure, then that would be like benzyl. How that would look on that.
We go through some examples to see where we see benzyl. But for this example, let me have like the expanded structural formula, so you see why it is phenyl, not benzyl. So you have like this. So you have like CH3, right? Then you have CH, and then you have CH2, and then you have CH2, CH3. Did I do this correctly? Right? So you don't have the things that are attached to these. So here You know, when you look at this, you don't have CH2 and then the rest of the molecule attached to something. Does that make sense? And then we have some examples where we see. Any question? Good? Okay. I may give you this in the exam, so it's more fun to have like more carbon, hydrogen. Road to phenyl. Okay. So now let's look at this. And I remember one of you asked me about like this, how do we name this compound? You know, so now we're talking about how we name this. So again, here you have like a phenyl group, right? And I use another color. Right? Can everyone see why it is phenyl? Because one hydrogen is substituted with something else. And here you have cyclopropane. Remember cyclopropane, cyclobutane? We had like these things. This was like a house. This one was a... We say cyclopropane, cyclobutane, cyclopentane, cyclohexane. Remember those in chapter 1? So this is cyclopropane. So you can name this compound as phenyl cyclopropane. Okay? Or you can name it some other way that I'm going to mention here. So you may, as your friend mentioned, you know, you may wonder that I want to name this compound still benzene, that something else is attached to it, okay? So the formula of this part of the, so this part is an aryl and the formula is C6H5. What about this part of the compound? How many, I guess I have the answer. So just ask me if you have any questions. There are like 2 hydrogens attached to this carbon, right? There are 2 hydrogens attached to this carbon, and there is 1 hydrogen attached to this carbon because 1, 2, 3 bonds, 1 more hydrogen, right? And if I write the formula, it is C3H5. Can anyone tell me what is this? Propyl, right? We call that propyl. But because it's a ring, we call that cyclopropyl. And then we have a benzene ring attached to it. So you can call this whether phenyl cyclopropane, or look at it the other way. Call this cyclopropyl benzene. And we have like an aryl group attached to an alkyl. Can everyone see that? Questions? Okay. This is the same one, the pen. Now, let me see. Okay. And I also named this, the example, 2-phenylpentane. We just talked about that, like, right? So that was clear, I hope. Now, we want to name it the other way. So if I write the formula here, this would be C5 if I count 1, 2, 3, 4, 5, and then 3 and 3 is 6 with these guys, 10, 11. C5H11. What type of substituent it is? What group it is? Yes, but what is the general group, like alkane? What do we call this? Alkyl, right? And then because we have 5 carbons, it would be pentyl. Okay? And do you remember that when we had more than 3 carbons in our alkyl group, we had different isomers, right? Do you remember? Because depending on where we attach, how the isomers are, how we have the carbons and hydrogens attached to each other, we can have different structures. Like remember isobutyl, for instance, we had like tert, like sec, butyl, those guys, right? So here, in this case, the second carbon in your pentyl is attached to something. Okay, so we call that 2-pentyl benzene. Can everyone see that? Is that clear? So there are two ways to name these compounds. And if I ask you for one, I don't try to be confusing. I just stick with one. Okay, but you should know both because you don't know which one I'm going to ask. Okay? Are we good? Yes.
Why is it a benzene if it only has 5 hydrogens?
Because there are like two ways to name these types of compounds. We have like an aryl, an alkyl. Basically, this is your aryl, this is your alkyl attached to each other. So depending on how you look at it, you can name it both ways. So if you look at it as if this is your alkane that has a substituent, if you look at this as your substituent, you call that phenyl. If you look at this as your substituent and your benzene as your main compound, you call that benzene. Does that make sense? It's kind of like dichlorobenzene that you have, like you said, we had like 2 chlorine substituted, right? But the name of the compound, the main compound is benzene. So it depends on how you look at it, but both ways are correct. Great question. Any other questions? Okay. So now I have like a challenge for you. Anyone wants to draw dibenzyl? For extra credit, of course. Yes. Since we have like marker deficiency, you can just like draw here. And can you explain how you write it too?
Yeah. How was it on the eraser?
Oh, yeah, yeah, you just do that. When I'm lecturing too, I'm just writing and then it changes to eraser. Okay, so what was benzyl by itself?
Benzyl is... Oh, it has a CH2. Yeah, that's right. So would it have like a... Be like, can we erase?
Yeah, sure. I mean, it's like this one. Yeah.
Okay.
It's this one. iPad and its features. Is it erased? Okay.
So it'd be like...
So what was the original thing that your friend wrote? What was that one? Diphenyl. And also your book called it biphenyl, so whichever you say is correct.
Would it be like that?
So first of all, remember to have like the double bonds in benzene ring. So this is benzyl, yes. Now you have 2 of that.
Okay.
How can you write 2 of that?
Dibenzyl.
Uh-huh. So, yeah, so this is, can you point at this? Yeah. So this is benzyl, right? So now you have 2 of that. You want to attach 2 of those together. So you can write, if it's easier, another benzyl here. Can you draw another one? Because we have 2 benzyl.
Okay, so it'd be CH.
Okay, so now you want to attach those to each other. How do you think we should attach? If you just like want to make a bond between the this benzyl and then the other one, right? How do you think? So this is benzyl. So the structure till here, it should stay the same, right? What I mean is that you cannot attach anything here or here, here, because you attach something here. Does that make sense what I'm saying? And then the same thing for here. This structure.
Can I try it again?
Yes.
Okay.
So you have like the answer basically. You have like two benzyls, but you want to connect them to each other. And you cannot connect anything here. You cannot connect anything here. But you can connect these two with each other. Exactly.
Okay.
Does that make sense?
Yeah, that makes a lot of sense. Yeah.
Perfect. Good. Can everyone see why we attach them like this and not the other way around? Good. Okay, thank you. And I have like some other, so this is the answer. See what your friend wrote. And I also have like more examples here, but we're running out of time. So make sure to draw these structures. And then ask me if you have any questions